Okay, so in this video, I'll walk you through what you need to do to complete the worksheets. So starting with the one for the background, and I will just follow the worksheet, following the instructions in the worksheet. So the first step is going to the NCBI homepage. So here's the website. I'm going to open a new tab for that and just paste that into the address box to go to that. It does tell you, once you're here, you will click on all databases and select the gene database and type in the protein name or the gene name, PTGS1. So it has this as the only biggest option. I think this is the reference sequence, but you also have a number of other options here. They are different species. So there is the mouse, the rat. This is the human PTGS1, and this one is also human. So either one will work. You also should open the PTGS1. So I will, this is PTGS1, PTGS2. So I'll open that as another page. And while that opens, I'm just going to tell you, so this is the full name is here, gene ID number, and all of that. And the summary for this one and for PTGS2, and if you forget to click on the gene database, it will open up all of the possible database entries that matches the PTGS2, and then you just have to select the gene. So I'll show you. It actually shows up this as well, which is cool. So it's the gene, and maybe because I have recently opened it, that's why it's coming up. Otherwise, you can just click here to open the gene entries of PTGS2. And then you will see the same thing here. So the summary, both of this summary and this summary, is what you need to be able to answer questions 1. Oh, that's not necessarily the right answer, but question 1, question 2, question 3, and question 4. So take a pause on this video, read those, and answer the questions. And then question 5 and question 6 are thought questions. They are not directly answered by the summaries. It's more for you to think about and try to apply and draw some conclusions from the information you have. And then the rest of them are actually directly from those pages. So those are for PTGS2. So the full name for PTGS2 is, the official full name is this one. You can just copy it and paste. It's prostaglandin endoperoxide synthase 2. And then the ID number is this one. And you can just copy and paste. I use Command V, Command C for copy, Command V for paste. You can do Control if you're on PC. And then it asks you where in the human genome it is located. So you have to scroll down. And for PTGS2, it is in 1q31.1. So that's chromosome 1, arm Q, and the banding is 41.1. Or 31.1, sorry. I didn't copy, so I'm doing it again. And then it asks you to obtain the reference sequence for the RNA. And to do that, you will go on this right column here and scroll down until you see reference sequence RNA. And this is basically a link to that nucleotide sequence. And it opens here. Again, it has a bunch of information, a locus number. So it asks what is the accession number. So accession number is going to be here, which is the same as the locus really. And then it asks you to actually save the file with the sequence, FASTA formatted sequence. So you click on FASTA. You're copying the title and the full sequence into a Word file. So open a new page, a blank document, and paste. That's it. Actually, if you click on this icon, it will show you the paragraph markers. Yeah, so this is describing you how to do this. Basically, you don't want to have all these paragraph markers. So you can go to edit, find, and then replace, or you can click here on this little arrow and click on replace. So this is the find toolbox, and then if you click on that, it opens this little menu for the replace. And then if you type in this in P, it typed in the P here, so I'm going to delete that P and type P there. It found all of the P's, and then I don't type anything on the replace, and then click on replace also. It's replacing the paragraph markers by nothing. So now I don't have a paragraph for each line. That's how Word would interpret it. But I do want to have the paragraph marker at the end of the title page. So the title ends with the mRNA, and then I'm gonna hit the return button, and then the sequence starts with AATT. And I can double check that the sequence starts with AATT. Perfect. Now I can save, and I will save as PTGS2 RNA. The docs is just the extension, so I don't need that. And I'm going to save it on the desktop. Now, I have already done this before, so I already have the file. So I'm going to replace. You're not going to have that message. And then it asks for me to input here. So you just click on that, browse my computer. I saved on the desktop, so I can go to the desktop and look for PTGS2 RNA and choose. Now I need to obtain the sequence for the protein, so I will do the same thing with the protein by scrolling down here until I find protein. So I'm already on the reference sequence for the RNA, so the protein here will be the reference sequence for the protein because it's the protein associated with this RNA. So I'm clicking on this protein, and it will open the protein page, and again it has some information. What is asking here is for the accession number. So you go to here, NP, it will be the protein accession number, and you paste it in here, but it's also asking for me to save the same FASTA sequence. So I'm going to save the FASTA sequence. And the reason to save this is just so that if your computer crashes or you need to stop, you have all these sequences saved in your computer so you don't have to redo this thing again. File, I'm just gonna open a new document. I could also do Command N on there and then save. And this time, oh, let's save the entire sequence, never mind. This time it's PTGS2 protein. Save the space there, so I'm deleting it. Save. Again, I have already made this, so it's asking me if I want to replace. Yes. All right. Now it wants me to go to Expazy website for the protein database. So I will go to one of these tabs to go to Expazy. And then I'm typing in PTGS2. And I'm looking for, I could have done that earlier actually, and look for the uniprotein KB database, and then search again so that it goes directly into that. You could also click on that database listed on the bottom there. We're waiting for the website to open. Again, it has a number of different choices. All of them seems to be the prostaglandin synthase 2, and but only the top one is the human one, so that's what we want. We want the human prostaglandin synthase. And here I have some information. First is asking me for 3 alternative names. So you can go to names and taxonomy to, get a shortcut on that. So you can copy and paste some of these names in there. One is cyclooxygenase 2. You can also type it out, but since it's recognizing the actual characters, if you have a typo, it won't recognize. And the feedback you will get is not as helpful. And then some of the other name is prostaglandin and upper oxidase synthase, and so on. Okay, what type of drugs targets these proteins? And then for that information, you will look up in here, and they say they are the target of non-steroidal anti-inflammatory drugs. You can do your own reading and read the whole entire content. And what modification produces irreversible inactivation of this protein. So if you continue reading, aspirin produces irreversible inactivations to a serine acetylation. So a serine acetylation is what inactivates the protein. And then it asks the actual amino acid type and number. So the type is serine, and we usually write it like this, and then the number. And then the actual number, we can scroll down to this list. Site of aspirin acetylated serine is 516. So the way we do a serine 516, and I know it's serine because that's what I wrote here, and then 516 because it's listed as the as here is also saying it's serine. All right, where in the cell it is located, I can also find that information by scrolling up or down. I don't know which direction to go now, but here. It is in the endoplasmic reticulum, or ER, and it's highlighted in the image. Pretty cute, right? All right, so this is all that is asking me, and I can submit and save. I skipped some of the questions, so it will give me feedback on some of the questions. It happened to be correct. So the ones that I've skipped is not giving me, but it's giving me some feedback for the questions if they are correct or not correct. So you can check your own work right there. And then for the second worksheet, we're doing a sequence manipulation. So we're starting that, and it tells me to, again, goes to Expazy to the resources A to Z. So going back to the home page, I can just click back. Resources A to Z, and then go to translate. And here it's asking me to copy the mRNA sequence. So I have the file here, and I can come back to this file and copy the whole entire file sequence. And not here. Here, paste it in. I like the verbose. It doesn't matter. Either one will give you readable data, and I'll click translate, and then you have to scroll down to see it. So I see frame 1 has a lot of little pieces that could be translated, and then frame 2 has one big chunk. Frame 3, 4, 5, 6. So it looks like the biggest chunk that is translated is this one, right? Starting with this methionine and going to this stop here. So this would be MLARA. So what we want to do, well, first is asking which frame seems to be correct. The frame that seems correct seems to be the 5', 3', frame 2. Okay, so next it asks me to compare the highlighted in red sequence with the PTGS2 protein. So the protein sequence here starts with MLARA LLL. And the sequence highlighted in red is also MLARA LLL. So it seems to be the same. If I were to copy only those, I can't because there's more. I was going to count the characters, but this is not in a compact version. But let's just check the end of it. It ends with KERSTEL. And here it ends with KERSTEL. So it looks like it's the correct protein, at least the beginning and the end are the same. So we can trust that this is the correct protein. And then it asks me to save, and I think it's just this, it's not, I'm not very clear there in my directions, but let's just save the sequence highlighted in red, so only the part that becomes the protein. And you can open a new Word file and save. And if yours look a bit different because you had compact instead, it doesn't really matter. It's fine. So just translate, and then you just have to save so that you can submit it here to show your work. T, translate, choose. Okay. Now we are comparing the sequences. What do you think will happen to activation sites and to especially to the amino acid that is modified by aspirin? Do you think it's conserved or not conserved? At least in terms of the comparison between the two proteins as well, you should be able to have a hypothesis for that. So go ahead and pause the video and write out your hypothesis in your own words. So for this comparison, we need to go to this website. This one, it saved as a link. That's interesting, but I don't want to save here because then it goes away. So don't just click on that link. You can right click and then open a new tab if you want. If you have a different version, it might not do that. This might look a little different. Sometimes when I open directly, it looks different. Don't worry about it. It works the same. And what we want is the PTGS sequences that is on the original page. So you can again right click here and open a new tab, or just open another page so you don't go away from that, to open this content and download this. Okay, so you will click on the content here and try to download the sequences. It keeps doing that, huh? You can right click and download linked file. Open as a separate file, because if you open on the browser, it will give you errors. once you're trying to follow up on the next step. Here you should be able to do it just fine. Come back to the cluster omega. Let me try again. I had tried more option. You want to be input not aligned and then submit. Yeah, so it will open on the browser like this, but this tends to give you an error if you copy from here. So it's easiest if you just download it as a file and then open from there. So this is the alignment that you're looking for. And then from this alignment, so you've already typed out here, you want to copy and paste the alignment itself. So copy the whole entire thing. So when saving an alignment, it's very common for things to get jumbled up. For example, here they are supposed to line up and this does not look right. So one thing we can do is, first of all, just make the layout narrow to increase the space you have, and that might take care of the issue. But you might still have some misalignment, and you definitely don't want these characters, which indicates, you know, the conservation of the aligned nucleotides, to be off. So you want to select the whole thing and choose Courier font, because Courier will make all of the characters the same spacing, even oh, that's too big, 10. Even like spaces will take up as much space as like actual, oh, that's still too big, 8. Okay, that's better. So all of these are correctly aligned, and the blue dots and paragraph markers is because this is selected. We can deselect that to make it cleaner. And then that's what we're saving. As Clostal W. And then I'm submitting that. It's an alphabetical order, so it shouldn't be that hard, but. So here we have asking you to identify what the symbols mean. And you can see that by looking at the alignment. So the alignment that has all identical residues is indicated by the asterisk. So identical is asterisk. And then we know that non-homologous, or if they have no relationship to each other, we have spaces. We have just, there's no agreement among them. So none, no characters. Now the question is, which one is highly homologous and which one is less highly homologous? And to do that, you might want to consult a table to see, for example, F and V, are they closer related than K and R? Which one is most similar to each other? And you can figure that out by consulting an amino acid table. And so let's look at the serine 516. So the 516, so this is on the human PTGS2. So the 465 is this one, and this is 525. So 516 would be 10 before this. So right, 25. How about this? 25, 24, 23, 22, 21, 20, and then 19, 18, 17, 16. It's a serine. Good. Good, good sign. So the serine, it's serine all around. So up until down until the coral, the serine is present in that locus as well. So that is an identical. So serine 516 is conserved among all the species, which indicate, first of all, that aspirin um, works in all of these species and works in fact, affects potentially PTGS1 and PTGS2. We already knew that, so it's just confirming. Indeed, it has to be there because otherwise aspirin would not work against PTGS2. And the fact that all the other species has it means it's an important locus. It's an important amino acid for the function of the protein, and likely aspirin also has pain relieving effect in all the other mammals. I don't know about coral. I don't know if pain is sensed by coral, or how is this enzyme involved in pain perception, but it is also likely inhibited by the presence of aspirin, which might actually be a bad thing. It might be very important for the function of the coral. But anyway, so this is the activity. Once you type out your answer, you're done, and then you can just submit, and your work is done. After you complete this, I'm not going to go over this because it's not necessary for me to walk you through. But once you complete it, go to the mindset self-assessment and try to answer as honestly as possible. After the self-assessment, you can watch one of these 2 videos, and then we'll meet up to discuss this material a little bit in our synchronized session. If there was anything here that I went through that you don't understand, you can either email me or we can address your questions in the synchronized session. And or if you're not able to open at that point, you can go to growth mindset discussion and share your thoughts about the growth mindset piece. Okay. Thank you all, and I'd love to hear your feedback about this format. Thank you.